In this question, we're asked for the one or two word phrase that best describes the shape of the SF5 plus cation, and then we're asked for the smallest bond angle between the sulfur and fluorine bonds in the SF5 cation. In order to answer this question, we need to draw the Lewis structure. And to do that, we need to count the valence electrons. So here we have 6 plus 5 times 7 minus 1, because it's positively charged, so it has one less electron, 35, which is 40 electrons. Now, we want to put the least electronegative atom in the middle, which is sulfur. Fluorine is the most electronegative atom. So then we want to bond this to, I don't want to put that like that, I'm going to put it this way, 5 fluorines, like so. And then I'm going to go ahead and put 8 electrons around each of these 5 fluorine atoms. Because if we have 5 fluorines with 8 electrons apiece, that gives me the 40 electrons and saves me having to count all of them. So once I put all the lone pairs on all of the fluorines, I will go ahead and move on. So one thing to notice is that I expanded sulfur's octet, and that is allowed because sulfur is low enough down on the periodic table. So that's not an issue. So now I want to minimize the formal charges. Well, fluorines, all of them are the same, want to have 7 electrons around them. Count the dots as 1, count the dashes as 1, and they have 1, 2, 3, 4, 5, 6, 7. Once 7 has 7, it's neutral. Sulfur, on the other hand, wants to have 6 electrons around it, and it has 1, 2, 3, 4, 5, making it positively charged. So this is a good Lewis structure because it has a positive charge. I knew it was going to because it had the overall species has a positive charge. So, and the sum of the formal charges has to add up to the charge on the species. And I was going to want to put that positive charge on sulfur because it's the least electronegative, it's a central atom. So this is a good Lewis structure. Now I want to count the domains. I have 1, 2, 3, 4, 5 domains. 0 of those domains are lone pairs. So I have 5 domains, 0 lone pairs. If I switch to this page I got on Wikipedia, if we look at 5 domains, looking this way, 0 lone pairs looking this way, I get trigonal bipyramidal. So this is the shape, it's trigonal bipyramidal. Now it wants to know the angle between the sulfur and fluorine bonds. And to show the angle, it's going to be a little bit easier to see on the Wikipedia page. So this is the trigonal bipyramidal shape, and here are my possible angles. If I go from, in our cases, are sulfurs and fluorines, XAX, or fluorine, sulfur, fluorine, this is a 90-degree angle between this fluorine, this sulfur, and this fluorine. If I were to go from this fluorine to sulfur to fluorine, here, that's a 120-degree angle. This is a so-called equatorial plane. So these 3 fluorines are on the equatorial plane. So therefore, they're having a 120-degree angle. If we were to go from this fluorine to this sulfur to this fluorine, that's a 180-degree angle. It's a straight line. So the smallest angle, which is what it asks for, is 90 degrees. Fluorine, sulfur, fluorine, fluorine, sulfur, fluorine, fluorine, sulfur, fluorine. There's lots of them, but they're 90 degrees. If you look in your textbook, you can find these angles on a chart, and you can look them up directly, and you don't have to really think about it too much. So here, the answer is 90 degrees because they ask for the smallest angle.